Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
All right. Welcome to another episode of Engineering Tomorrow. I am your host, Brian Gomsky. We are in the Chesterfield Valley again. I have a very special guest today. His name is Jim Johnston from Altaire. Jim, how are you doing today?
Not too bad. Thanks for having me today.
Good. Glad you're here. So I have a confession. It's been a little while since we've done our last podcast. It's been pretty crazy around here. Definitely getting some new product lines, yours included, for Midwest Machinery. Jim, tell us a little bit about you and Altaire and what that product is.
Sure. Well, the easiest way to be able to start it is my name's Jim Johnston. I'm based here in St. Louis, Missouri. Relocated here from Southern California about 5 years ago, and myself and the three other principals of Altaire Systems have incorporated in St. Louis because we believe this is a key market, and we can support everything east of the Mississippi and west of the Mississippi. Everything's 3 hours by plane.
What exactly is Altaire? What is the solution?
Essentially, Altaire, we produce our Adapt units, which provide high-intensity dehumidification for chill water-based air handlers.
You sell and provide a system that goes on to air handlers.
Correct.
Let's back up and talk about what an air handler is for some of our younger people in school and some of our young engineers and contractors.
Easiest way to be able to put it is an air handler is a large shoebox with some copper coils on the inside that typically use water to be able to extract heat out of the air coming in from the outside or from the building space. When that air comes across it, the water sucks the heat out. On the backside, you get cold air that then makes your building not hot anymore.
Okay. So typically with air handlers, you're going to have chiller, boiler, tower solution.
Absolutely.
Okay. So what I find interesting about air handlers is all of how it's evolved throughout the years and how many pieces they keep having to bolt onto these things to solve problems. Mm-hmm. Go through, before we get into where Altaire fits into air handlers, can you walk through the different pieces? What are these entropy wheels and all recovery? Like, what are all these different pieces trying to accomplish that your basic air handler falls short on?
So an air handler, because of the fact that you're extracting all the heat out of the air, is just like when you walk outside on a hot, muggy day with a cold glass of water. Mm-hmm. What happens to the outside of that glass? All of a sudden sweats.
Sure.
You get condensation.
Ruins coffee tables.
Absolutely. When that condensation happens, that water needs to go somewhere. Standard air handler will typically drip off the coils it causes some of the issues that our Adapt units solve. Mm-hmm. When that water starts dripping down, it goes into a condensate pan, and then it gets drained away. Causes all sorts of issues. Typically, those drain pans need to be cleaned out. The drains need to be unplugged. And if the air handler was improperly designed or the climate has changed, which is one of the issues we're all facing, a lot of times that water cannot get away fast enough.
Oh, really?
And you run into some significant issues called the low delta T syndrome.
What's that?
What ends up happening, it's almost like submerging the bottom eighth to a quarter of your the radiator in your car. Uh-huh. And if you're having the same medium that you're using to extract heat out sitting and covering the bottom of your coils, that thermal transfer is not going to happen as well.
Okay.
So you lose an extreme amount of efficiency. Plus, you also get all the negative biological issues that end up happening, and puts a lot more load on your plant that wouldn't typically need to be there.
Are a lot of air handlers outside?
20 to 30% of them are.
20 to 30%. And then my guess is when they are outside and it's 110 degrees outside, your maintenance guy, he doesn't have much motivation to go out there and mess with it.
That's true. Very true.
So you've got the lack of maintenance, you've got condensation buildup. What are some of have there been any solutions just within the air handler itself people have tried in the past to try to alleviate this?
Sure. So a lot of times what will end up happening is they will use either a preheat coil, what's called a desaturation coil, which is essentially it's a fix to use a little bit of the heat they've extracted out of the air to reheat the air downstream. Because you can't take all that cold air and immediately dump it into a building, or essentially it starts raining in the office spaces.
Oh my gosh. So let's say you do have a problem with condensation buildup in the bottom of your air handler. How does that affect air quality within the space?
Well, we've looked at hundreds and sometimes thousands of air handlers. If they're not being properly maintained, or even if they're on just a standard PM schedule, we've seen things from pretty nasty biologicals, whether it be mold, mildew. We've seen large cap mushrooms growing on the inside of the condensate pans.
Oh my gosh.
Yeah. And on top of that, you also get an extreme amount of rust because things get left in there, and it depends on the construction of the condensate pan, but those tend to wear out, which means all that water just goes inside the air handler instead of drained away.
Sure. And then obviously this could be a major issue in hospitals with people with weakened immune systems. And then not to mention, we had recently actually published an article on Engineering Tomorrow blog about air quality conditions in the workplace and how it's actually considered a syndrome. People who are more susceptible to getting sick with poor air quality in your office, productivity goes down. It's really a problem all around.
Yep. So you brought up two really, really important issues. First is the indoor air quality piece. Harvard actually just released a study last year talking about as you essentially start dialing down the outside air to be able to remove a little bit of that problem, the CO2 builds up because people are exhaling.
Oh, yeah.
It talks about all the productivity lapses. It's one of the most in-depth studies we've ever seen.
Oh, wow.
And then people that are definitely mold sensitive, it causes issues with allergies. People start developing the flu and the cold more. Those spores get really, really nasty. And then when you talk about the healthcare environment, because of the stringent codes that ASHRAE puts forth and the amount of air changes and everything else, not only do the codes continually modify to suit the existing conditions, but you also run into issues where the surgeons in the operating suites, the managers of the NICUs want their specific indoor conditions to be personalized to them.
Okay.
Which causes a lot of wear and tear on the existing systems, especially when, here in St. Louis, where we get 3 to 4 months of pretty hot and nasty weather. That is a very, very hard deficit to be able to make up. And when the system's cranking at 100%, a lot of times you end up getting cast off because they're running the fan a lot more. Your condensate pan's not draining off properly. That's when, for those really, really critical areas, not to exclude any of the occupied spaces in the hospitals, but you start getting a lot of the healthcare acquired infections, which the lawyers are hopping all over. There's been 7 over the past year and a half that have been multi-million-dollar lawsuits against hospitals because of mold on blankets, which is caused by the air handling system.
Oh my gosh!
And people just breathing all that stuff in that's being cast off into the ductwork.
Sure. I think the maintenance providers at the hospitals are doing all they can. I'm sure there's a lot of bureaucracy involved with that, and a lot of decision making on that side as well. Where does Altaire fit into solving this problem?
So the easiest way to be able to describe what Altaire does, and with our Adapt product, is we treat the issue at the source, which is the outside air coming into the air handler.
Okay.
And the reason we designed our Adapt unit the way we did, and we did it as a pre-treatment module rather than internal to the air handler. We wanted to address the problem at its source in a much more compact, much more applicable, easy to apply manner.
Okay.
Than going after a large piece of equipment that then will continue to rain and cast water all over the place and run into the exact same issues, other than just relying on a couple degrees of fan heat to be able to bring the temperature off saturation. So what we do is our units, we have both the Adapt 2500 and Adapt 5000 unit.
Okay.
which is a 2,500 CFM and a 5,000 CFM unit that are stackable, gangable, so we can be as modular as possible. Our unit will be brought in. We can fit through a 30-inch mechanical room door.
Okay.
Brought up a service elevator, and then our unit is cut into the outside air ductwork ahead of the air handler. So what ends up happening is once our unit is installed, minimal support, maybe pour a pad or a little bit of a steel structure to be able to support underneath. We are using the native water that's feeding the existing air handler.
Okay, so you're tapping into existing.
Yep.
Okay,
Exactly.
so minimal piping.
Correct.
Okay.
And 120 power.
Okay, and not too much power requirement either. Okay.
Nope, not at all. And typically power is already there because it's serving the existing air handler. Once our unit goes in, our unit is taking that dehumidification load, which is what is the biggest energy hog and the hardest thing for an air handler to be able to control, and taking it out of the equation.
Okay.
We'll go into a little more of the technicalities of it, but essentially everything that's going to come off the backside of our unit is going to, all that air is going to feel like Phoenix in May.
Oh, wow. Okay.
And what that means is the air handler, all it has to do is what's called trim to sensible, which is one of the easiest things and what it's actually designed for.
Okay.
So every air handler out in Phoenix, they're running into a complete opposite issue where they actually have to humidify some of the air.
Sure.
With ours, we're getting it where it's comfortable, it's safe, and the air handler doesn't have to worry about maintaining and managing this intense dehumidification load.
Okay. So you're taking a lot of strain off of the air handler. You're removing the buildup of condensation in the condensation pan, the rust. So you're improving the lifespan of the air handler. The components are operating less strenuously. You're getting rid of the mushrooms, the mold, the mildew, and you're providing clean air
Correct.
within the space.
Yep. And there's one other piece because everybody wants to talk about energy. Our units are an energy play as well because of the fact that we're removing such a distinct load off of the central plant.
Okay.
When the unit's actually able to operate as efficiently as it should, that takes a significant amount of cooling load away. And then on top of that, we have a few different control strategies to be able to do what's called our night protection mode, which we'll go into here in just a little bit. But when the system's operating as efficiently as possible and not having to handle such a massive load, the energy savings are significant, and we can prove those all out.
Visually, we've talked about just so people can picture what this looks like. You've got the air handler, which looks like a shoebox, and you're basically a mini shoebox that goes in front of the air intake.
No, that's exactly right.
Okay, and then just a couple pipes and a power cord. How does this need some sort of computer brain to control? How does that work?
So that's where the guiding ethos when we designed our ADAPT system, which was actually developed between myself and one of my business partners, Jim Meacham, who was out here a couple months ago. We were up on the 5th floor of a barracks in Kunsan, South Korea, watching F-15s take off.
Oh, wow.
It was in the middle of winter, but because of the fact that it's the winter time, you're 4 months away from summer. What ended up happening is we looked and said, how could we solve this issue in the most easily applicable, simple, and easy to install manner possible that would get the greatest amount of good and greatest amount of energy savings? And we came up with, well, there's the issue. Everything that's coming in from the outside needs to be treated. This air handler can't handle that load. And if we go inside the air handler, you're going to have to double the size. And most existing mechanical rooms don't have the space, don't have the expandability. And if they did, you'd be knocking out a bunch of cinder block walls and dealing with all the rest of the nonsense that goes along with heavy construction for what we consider kind of minimal gain.
Sure.
But yeah, so with the controls piece, we've had both between myself and my 3 other business partners, we've got roughly 50 years of controls experience.
Okay.
We designed an onboard control system.
Okay.
That will maintain everything up into maintaining the air handler downstream and getting everything to operate as one cohesive system. So what that means is we can see if someone has decided to go in, I don't know, maybe do a little bit of a workaround and tech screw the outside air dampers closed because they're running into dehumidification issues, which can't say we've never seen that before. Sure. We will know when it happened, where it happened, the exact time that it happened, and how long those kind of measures were in place. We also see differential pressure across our unit. We see exactly what the existing conditions are being created inside the occupied space.
Okay.
Because that's really one of the biggest things. You need to know what's going on inside the building so you can control to what you need to be able to provide.
Sure.
Other than just having your system cranked 24/7.
Okay.
And we need to know how that the air handler downstream is operating and what the outside air looks like coming in, so we can modulate it as efficiently as possible. And the nice part is, with everything already being on board, once you hook up that 120 power, we can remotely commission and never have to worry about control sequencing, programming, all the rest of the issues that typically go along with a full controls upgrade.
Okay.
Ours is in a nice stainless steel box that nobody's really going to need to deal with, but can integrate, since it is all open protocol, because we're tritium based. We can integrate with anybody's system out there with minimal issues.
Okay. So, is there any maintenance required on the system at all?
Yeah, changing the filters, just like an air handler.
Okay. And how often are you wanting to change those?
So we have two different ways you can do that. You can either put it on the PM schedule, same as the air handler, if you need just prevent or periodic maintenance.
Okay.
Or you can go off our system, which will tell you when to change the filters on the adapt unit. Because a lot of times when the filters get loaded up a little bit more with a little bit more of the water, a little bit more of the some of the nasties that they're built to be able to filter out, they actually operate more efficiently.
Okay.
So we look for that kind of optimal time, and then as efficiency starts to degrade, we'll send an alert to whether it's the existing control system or a wireless alert to the maintenance personnel to say, okay, it's ready. It's time to change the filters on the adapt unit.
You're listening to Engineering Tomorrow, always striving to bring you the best in commercial construction, design, and engineering.
What is the ideal installation? Are we talking retrofit? When you're first designing and installing in a new scenario, what is the ideal fit for Altaire?
So the easiest way to be able to say it is it's honestly both.
Okay.
And I'll start with new construction first. With regard to new construction, if it's a big MEP outfit that's designing a new facility and looking to squeeze a lot more equipment into an area that doesn't have that room for the equipment.
Okay.
With our units being able to free up additional capacity because of the fact we're getting rid of that dehumidification load, you can get smaller air handlers, smaller air handler coils, and then also a smaller chiller because of the amount of load we're taking off the proposed plant.
Okay.
And you're changing, well, not even changing, you're removing your design conditions, because rather than saying, okay, we're here in Houston, Texas, or St. Louis, Missouri, or Miami, Florida, well, all your design conditions now off the back of the adapt unit are Phoenix and May. Mm-hmm. That's pretty easy to design to because it's standard. You don't have to worry about that massive load and looking at all the degree days and figuring out what's worse, and then, well, what do we feel really, really comfortable with?
Okay.
On the retrofit side, we're problem solvers.
Okay.
If your system's operating as efficiently as you like, you're not running into issues, you're not having people calling up and saying our building smells like a towel in a wet shower, or you're having people sneezing all over the place or yawning because somebody's dialed back the outside air. Great. Let the building continue to operate as efficiently as possible. Where we fit is you don't have the room for an ERV system, putting in a wheel, putting in some sort of massive system that typically you don't have the real estate for. Mm-hmm. But you need to solve the problem, because if not, you're opening yourself up to potential liability lawsuits, people leaving because of the fact that they just don't like working in a building that smells like a wet sock.
Sure.
Those are the kind of deals where we can go in, and because of our modularity, because of the fact that, well, I mean, here in St. Louis and other markets out there, a lot of times you're dealing with the existing buildings that were designed back in the 40s, 50s, 60s.
Yep.
So you're dealing with the cramped spaces, you're dealing with winding walkways. With our units being able to be put into a service elevator, brought up to whatever floor it is, hand trucked into the mechanical room, and to be able to fit through a 30-inch door and broken down or site assembled. It's a great solution to be able to deal with those problems in a very, very cost-effective manner without having to crane a piece of brand new equipment in that may or may not fit and may or may not solve that issue. Okay.
Let's say somebody decides this is going to be a great solution. What is the install time on Altaire?
So The standard install time, and we like to say, just from a conservative standpoint, 1 day.
Okay.
But especially if it's over a weekend where that's typically everybody scrambling against the clock.
Sure.
To be able to get a new piece of equipment in, our unit could be changed over in as little as 6 hours.
Okay.
Because all you're doing is cutting into some ductwork, placing the unit there. You can actually still have the existing system running, because the fact it's just outside air, you're just losing a little bit of filtration. And when that ends up happening, all you have to do is slide our unit in and then hook up power, hook up water, and with it being 2.5-inch lines, that makes it very, very easy and applicable to install.
Okay. Do you have any type of ROI payback calculators, or how does that work?
So that's actually something we're putting together right now. It seems like it should be a really easy question to be able to answer for all the way across, but every utility is different.
Sure.
Whether it's peak demand, whether it's off peak, what it's actually doing, if there's any sort of performance-based incentives that the utility is offering for dehumidification solutions, we'll have essentially the straw man built by the end of this month. Okay. And then ready for prime time right about the middle of February because of what we're doing with all the existing inputs. Okay.
Tell me about, you mentioned night mode. What is that?
So our night protection mode, this is where it gets really interesting, especially from an energy savings standpoint. Okay. So if you're, say, running a hospital with multiple ORs and multiple occupied spaces during, 6 to 7 months out of the year, especially in Florida, is essentially humid summertime. Mm-hmm. Every building maintenance personnel that goes out there to be able to maintain their systems leaves their HVAC system running typically 24/7. Okay. The interesting part about that is there's so many different ways to be able to how do I say this properly? You need to be able to keep your building positively pressurized, or if not, all the humidity that you're trying to keep out finds a different way in. Doors, windows, through the walls, cracks in the existing structure, whatever the case is. So when that happens, you can't just shut your HVAC system off, or you're going to walk into the next day and it's going to be a swamp. Okay. And the reason I'm saying that is our night protection mode. What ends up happening is when our adapt unit is installed, and it's directly ahead of the air handler. It doesn't matter what the outside air conditions are, both from temperature and humidity. We're able to essentially handle that load in the off hours. Okay. So say, I guess for simplicity's sake, an operating room is typically scheduled from 7 in the morning to maybe 7 at night. Mm-hmm. So you're dealing with 12 hours of typically having to run your air handler full bore just to be able to keep that room at the existing conditions that they need it. Mm-hmm. What ends up happening is when our unit is installed, we can switch to the night protection mode, and our unit will then provide warm, dry air. Okay. Which means you can either shut off or greatly curtail the amount of load that you're placing on your air handler. And it all depends on, turn down your chiller, what the existing system is designed for. And what that means is you're providing warm, dry air that doesn't have to be you don't have to manage to what's called your sensible set point. Okay. All you're doing is keeping your building positively pressurized without a massive energy load being placed on the plant. Okay. What happens then is the next morning, if, to say, surgery is scheduled for 7 o'clock the next morning, right around 5, even though your operating room is warm, it's dry. What will end up happening about 2 hours prior, we have an algorithm set up where we will kick the air handler on. And then all it has to do is trim to sensible, which means you're going for that sensible set point, which is a lot easier than handling the dehumidification load and the sensible set point as well. Mm-hmm. So it's a massive energy savings for 12 hours out of the day. Sure. I think being as humid as St. Louis is, every office building I've ever worked in, as soon as 5 p.m. hits in the summer, the air conditioner goes off, and within 5 minutes I'm sweating. Mm-hmm. And then you get in the morning, and it takes a couple hours to wring out the water in the space. Yep. And that sounds like a fantastic solution to at least keep the humidity out of the space, and without having to run your system completely 100%.
in the summer.
What's interesting is a lot of times, and I know we hinted at a couple of the workarounds, tech screwing the outside air dampers closed, or even just curtailing them way back. We see a lot of issues where some of the engineers on site will do that, but then not shut off their exhaust or throttle back their exhaust. So what ends up happening is you've just stuck a gigantic vacuum on top of your building, which then, even though you don't have a lot of air, outside air coming in through your HVAC distribution system, it's coming in through your doors, coming in through your windows, and coming in through every single place possible because of vapor pressure.
Sure.
Having us in there, you don't have to worry about it because then you got the positive pressurization, and it keeps all the nasty stuff out where it should be rather than in where people are actually occupying and can be a place of the greatest risk.
Yeah. Jim, tell me a little bit about your background. You mentioned you're kind of more 30 years in controls. Tell me a little bit about what you've done in your career and how you got to the point of where we're at today with Altaire.
So that's kind of that's a roundabout little story. So I'm actually a Midwest native, though I was a military brat.
Okay.
Essentially every 3 years I always get the itchy feet because my dad was a 21-year Marine. When I turned 17, I went into the Marines, flew helicopters all over the world, did that for about 5 years, met Al Gore, flew inside volcanoes, did all sorts of other interesting things. When I got out, I got my degree in international economics. I went to Mizzou, then got into big finance and energy out on the West Coast. Went from Vegas up to San Francisco, down to Southern California, and bounced around and did a lot of interesting things. Big infrastructure projects. A lot of federal contracting, especially on the mechanical side, with controls tied in. And then about 2.5 years ago, though I'd known some of the guys, my business partners peripherally, we all sat down and figured out that we all work well together.
Okay,
we're all good at solving problems. We're all good at figuring out ways to be able to address a very, very simple need that nobody's been able to address simply. And what I mean by that is there's ways to do what we're doing right now with our ADAPT system.
Yes.
But it's just not simple.
Okay.
You run into a lot of Rube Goldbergian type applications.
Sure.
Systems that are gigantic, systems that require a huge amount of capital investment, shutdown time, everything else. We all sat around and tried to figure out the most simple and easiest way to be able to do it. And that seminal moment was when we were on the 5th floor of the Kunsat barracks watching jets take off. Once that happened, we looked at every single way to be able to make our unit as easy to install, easy to apply, easy to control as possible. And our guiding ethos was simple. How do you do something that really nobody can screw up?
Sure.
Other than maybe piping something backwards, but that's an easy fix.
Sure. And it's very hard to design something that operates very simply. Coming from a programming background, just trying to make something as simple as possible requires way more work than just throwing something out there. So I can imagine you guys have put a ton of time and resources and engineering into this solution.
Yep, absolutely.
Can you share, are this manufactured in the United States? Kind of tell me a little bit about the hardware itself.
Sure. So would you like me to start kind of breaking down what the unit consists of as well?
Sure. Yeah, absolutely.
Okay. So we are made here in the USA.
Okay.
We are Buy America compliant.
Okay, great.
We're also a veteran-owned business since I was in the Marines.
Sure.
We are manufactured here in the Midwest. So lead times going anyway it's not an obstacle. We're not shipping from upstate New York or Southern California. We wanted to be able to make this as easy as possible to get the people the units that they need. And our unit, the reason we've designed it the way we did, I guess starting from outside in, and this is where it came down to the simple, but I'm looking for a simple way to be able to apply. We wanted the most lightweight but most robust material to design our unit out of.
Okay.
And what we settled on is 50-52 aluminum.
Okay.
It's the exact same material, or exact same metal they make Bass Tracker boats out of.
Oh, really?
Yeah.
Okay.
And especially with, the Bass Pro headquarters being here and everything being made down in Springfield, it's kind of apropos that we're talking about that.
Interesting.
The reason we chose that is when it rains or it's exposed to the existing conditions, it corrodes once. You get that nice little dust cover on the outside.
Okay.
And then it never corrodes again.
Okay.
Unless somebody decides to take a dissimilar metal screw and punch a hole
Sure.
in it. But, you can't fix people.
Sure.
And then you go down. The other pieces that aren't 5052 that didn't make sense are our controls cabinet, which is 316 stainless.
Okay.
And then we also did that for our condensate pan and for our filter racks. The reason we didn't do 302 stainless is because of the fact that still will corrode. 316 doesn't. We want to be as robust as possible, especially since we're actively pursuing the hospital market.
Got it.
We don't want things falling apart, and we wanted a 20-year lifespan, which was one of the other kind of guiding directions we had when we designed our system.
Okay.
Our coils are all electrofin coated because we wanted to make sure those aren't going to be falling apart 5-6 years down the road. Whether it's because of a maintenance issue or because of existing conditions or salinity in the air, whatever the case is, even though our filtration handles salinity as well. Okay. So,
and what's the lead time?
Typically, we're running about 10 to 11 weeks.
Okay.
And with the lead time as well, submittals, because of the fact that we didn't want this to be a custom unit.
Okay.
What that means is every air handler is typically a custom unit. It's built. Sure. It's built to the application. Since we designed our pre-treatment unit as the 2500 and 5000 CFM unit. Here's our submittal. It's the same thing over and over again. If they want more of them to be able to handle a larger CFM load, then we gang them and stack them. We can do 2 high and as many wide as possible.
Okay. So modular, it's a modular system. You just add on more.
Exactly.
Okay.
Exactly. All through a common duct.
There you go. I mean, back to being easy. Exactly. There you go.
Yep. Being easy and being redundant. Mm-hmm. So if for some reason, somebody backs something into one of our units, you have the other 3 or 4 of them still fully operating. And also we'll know there's an issue with the unit because of the onboard controls.
Sure.
So
do you think aside from your great new solution, do you think we've somewhat maxed out technology in air handlers? Or I mean, how many more wheels can we put in there?
Well, with the
lights or
and we can go into a different kind of rabbit hole with the lights piece, because that was part of our research as to whether or not we included the UV sanitizing lights.
Yeah.
Air handlers haven't really changed other than, the incorporation of wheels or potentially a desat coil, which people still play with a little bit as a fix. There's not a lot new to talk about other than how fast can you get it here? How can you build it? Can you make it modular? Can you make it site assembled, site built, whichever company you're talking about directly? Sure. Somebody's always going to come up with something new, but I mean, again, come back to that Rube Goldbergian kind of argument.
Right.
How complex do you want to make it? And what else could you really do that would be, 1, financially feasible, and 2, it's going to be working in 6 months other than becoming static in the system?
Sure. Jim, we touched a little bit on energy recovery. Can you tell me about energy recovery and how it relates to Altaire's system?
Sure. So this is where the real magic happens.
Okay.
For our adapt units, both from the control side and then from the coil arrangement, our unit is one of the only units out there that is compliant with the new ASHRAE 90.1 2016 guideline, where you cannot provide simultaneous heating and cooling.
Okay.
Without an exemption. What I mean by that is in our coil configuration inside of our unit, we slow the airflow and slow the water flow down across our unit because we want as much dwell time as possible.
Okay.
And essentially what we've designed is one common coil with a little bit of a space between it, that we're able to use all that low-grade heat that is being sucked out of the air going across those coils, just like the radiator in your car, to then provide supplemental reheat on the backside of that coil, because everything is counterintuitive for the majority of the people that don't live this on a day-to-day
Sure.
basis. If you cool all the air down coming through your air handler,
okay,
and don't warm it back up as soon as it hits the office space because it's warmer, it'll automatically condense, just like bringing that cold glass of water out into the hot, humid air.
Oh, okay.
And then you start getting all the nasty mold, mildew, and everything you see around the registers and office spaces, hospitals, unfortunately, and a few of the other spots. With what we're doing, there's two existing ways to be able to provide reheat currently.
Okay.
You can either do it hydronically or electric resistance.
Okay.
Resistive, excuse me. The hydronic way, it means you have to use a boiler. You provide hot water as a separate set of coils inside your air handler. But then after you've cooled the air down, you have to essentially temper it and warm it back up, which is energy intensive because you're using gas, or you put what's equivalent to a toaster.
Okay.
which is just a bunch of coils that warm the air back up using electricity, just like your toaster oven at home.
Okay.
Some people rely a little bit on the heat coming off of your fan, but that 1 to 3 degrees you're actually getting, that doesn't provide you a lot of margin for error, and you still run into all the existing issues that we've talked about before. With us, because we're extracting such a high thermal load out of the air, all the outside air that's causing all the issues, instead of kicking all that heat back to the chiller and having the plant having to deal with it, we then provide it's one common coil arrangement, but a secondary coil that will then use all that heat to be able to warm the air back up with all the heat it just took out of. Okay. So it's net neutral in terms of energy. It's almost like an energy wheel if you'd associate it that way, where you're using all the energy input and then using it right back into the downstream air to solve the problem, rather than doing what's going on right now where it's being kicked off. And with the ASHRAE 90.1 2016 piece, with us not having to provide any additional energy to be able to provide that supplemental reheat, that's a real key driver, especially when it comes to government projects, because you're being governed by the whole building design guideline.
Sure. What was the need and reason for ASHRAE 90.1?
The easiest way to be able to put it is everything is going off of energy and resiliency. Less systems, less energy, less things that will break.
Okay.
So, and because of the fact that is the way dehumidification is typically handled, it is a very, very energy inefficient process. So the whole building design guideline and ASHRAE came together and said, here's what we need to be able to do. We need to be able to get rid of this. Now everybody else figure it out.
Sure.
And everybody's come up with the train CDQ unit, the ERVs, everybody's looking for a brand new mousetrap. We've just come up with a very simple one that uses everything that's already there for us to be able to use.
Okay. So. Jim, I want to thank you for being on the show. This sounds like a truly awesome product, very Apple-esque in my opinion. Where can our audience find out more information about Altaire and get a hold of you guys?
Well, we can go directly through Midwest Machinery, or you can come to our website, which is www.altairesystems, ALTAIRE systems.com.
All right, great. All right, you guys are listening to another episode of Engineering Tomorrow. Thanks again. It's now 2020. And look for a ton of new content and episodes of our podcast, as well as content on our blog, engineeringtomorrow.blog. Until then, keep engineering for tomorrow today.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.